Salutations! Welcome to Stuff You Need to Know About Science. I, the most glamorous and charismatic Jack, will be here to teach you a range of scientific topics from all the fields. I'll also be joined with my gallant compatriot Alistair to assist me in these endeavours. In this episode of Stuff You Need to Know, or SYNTIC for short, yeah, that's never going to catch on, is it? Yeah, alright. Well, in this episode, we're going to be looking at the scientific method and its development throughout history. Exciting, I know! The scientific method underpins practically all of modern science, though especially the more empirical fields like physics, chemistry, and biology, and thus definitely warrants our attention today. So, the scientific method. What exactly is it? Well, attentive viewer, the scientific method is what scientists use to logically explore problems through experimentation to come to conclusions about that original problem. The exact process can vary from place to place in science, but the scientific method tends to look something like this. First, you pose a question, effectively finding out exactly what you want to know or investigate. Then, some research into the topic is generally necessary in order to better understand your question and how to approach answering it. After this, you create your hypothesis, which is essentially a testable statement that addresses your question. Around this hypothesis, you then construct an experiment and perform it, taking note of how you perform the experiment as well as its outcomes. After the experiment is completed, we now have to review how accurate the original hypothesis was. If the experiment doesn't support your hypothesis, then you best revise that beast and do some more experimenting. If it all checks out, however, you're all set to draw your conclusions and communicate your results. Easy, right? Great. Well, now let's look at the story behind the scientific method, how it's built up over time. Let's begin our epic journey through the ages and set the stage in ancient Greece. Now, we can probably attribute the creation of the scientific method to one particular Greek, and that fellow is Aristotle. Aristotle, unlike many other Greeks, theorized that in order to make conclusions about the world that we lived in, you had to find empirical evidence that supported your case. Whenever he wanted to find something out, he would first research what other scholars had written on the topic. Then he would find the public opinion of the matter, and finally systematically experiment to come to conclusions of his own. His method wasn't exactly ideal, but at least he'd nutted out that in order to actually come to conclusions, you had to make observations rather than just talking about it for long enough. And that's something, right? The next fellow who spearheaded the hammering of the scientific method into something that we can recognise is the noted Arabic scholar Ibn al-Haytham. Now, amongst other studies, he made great strides in our current understanding of optics and light. Namely, he discovered that the eyes absorbed rather than emitted light. Must have been a real eye-opener. I would apologise, but I'm not sorry. Anyways, enough digressing. What made this scholar special was his revitalisation of the scientific method in one of his writings, the Book of Optics. In it, he followed steps that looked pretty much like this. First, he would state an explicit problem based upon observation and experimentation. Then, he would test or criticise a hypothesis through experimentation, and then interpret the data, come to a conclusion, ideally using mathematics. And then he would finish by publishing the findings. Sound familiar? Well, actually, it's quite similar to our own modern scientific method. It's just a bit bare bones and requires a bit of tweaking. Also during the Arabic Golden Age, physician Al-Rawi introduced the concept of peer review in his book on the ethics of the physician. This served as a framework for the doctors of the time to share their work with other doctors who could then determine whether or not their practices were total bogus. And now we return to Europe in the Renaissance, between the late 1500s and early 1600s, where our scientific method further develops. The next notable figure in our story of the scientific method is Francis Bacon, who was a strong advocate of something called inductive reasoning. Inductive reasoning is essentially the idea that the scientific method should always start with the observation of phenomena, and having those conclusions be turned into a theory about how this phenomena is exhibited on a more general scale. Inductive reasoning happens to be the exact opposite of another vein of the scientific method, known as deductive reasoning, which just happens to be the reasoning that the famous mathematician Descartes believed. His rationale was this: due to the fact that the universe obeys a set of rules, if you know the rules, then you can predict what more specific things will do. This must have been quite the debate at the time, but now we understand that the scientific method can accommodate both at the same time. 1660 saw the establishment of the Royal Society, which moulded the scientific method and science in general in a variety of ways. Firstly, the Royal Society allowed for more peer review due to the greater centralisation of the scientific community. Additionally, it ruled that experimental evidence is more important than theoretical evidence, which, if you think about it, really makes sense, because one is actually being able to prove that something happens rather than being able to say that something happens. So, good stuff, Royal Society. And finally, we end with the one and only Isaac Newton, who, in 1687, wrote the Philosophiae Naturalis Principia Mathematica, which currently rates a 3.8 out of 5 on Amazon. In it, he used both deductive and inductive reasoning, a first in the world. And it was this which really did change the scientific method. Of course, there's much more to this story, and many more contributors who really did make a difference in the scientific method. However, it seems we've kind of run out of time. But I hope you've learned some stuff about the scientific method, why it's important, and also the developments it's made throughout history. Here's some food for thought till we see you next time. Since the scientific method developed in tandem with science, how independent from the scientific method is science itself? Anyway, we'll just leave you with that, and see you in 2 weeks, where Alistair will be talking about genetics and evolution. Anyway, until then, stay gravy. Roll credits.